Welcome back to the next Organometallics video. In this one, we're going to be covering olefin metathesis. All right, so this is going to be the last reaction, the major reaction for organometallics, and it primarily involves using alkenes. All right, so I drew a little bit of a setup already to get us started. And so what we're going to do is we're going to just look at the product of this reaction just to give us an idea of what olefin metathesis looks like. All right, so I created these two alkenes. They're identical, right? On one end, they have these two blue R groups, and on the other, these orange hydrogens. So we're going to see what the product of these guys are going to be during olefin metathesis. So olefin metathesis uses a ruthenium catalyst, right? And it uses a carbene ligand, right? If you guys forget what a carbene ligand is, it's a carbon, two hydrogens, and a lone pair. If you calculate the formal charge, you'd see that this is neutral. So an example of a ruthenium catalyst you guys can see something like this. So that double bond where both of those bonds are directly bound to that ruthenium, that is a carbene, right? So in this case, our ruthenium, if you want to pause, I'm about to say the oxidation state. Our ruthenium is going to be +2, right? That carbene is neutral, all right? And we have 16 valence electrons total, okay? So that would be the ruthenium catalyst. I'm not going to draw it out every time, so I'll probably just write over the arrow something like Ru. So what would the product of this be? So you always have to have those two double bonds still. So I'm always just going to put them back. Now the whole point of olefin metathesis is I'm swapping the ends of two alkenes with each other. So let's think for a second. Let's say I keep this guy constant, right? I'm going to take this and I'm going to leave him the same. So he stays put. So I'm going to swap this end. I can swap it with this end or the one in red right here. Which one am I going to pick? Well, if I swap it with the hydrogens at the bottom and I circled in blue, I'm going to get my exact reactant, right? No point in that. So I'm not going to swap it those hydrogens. I'm going to swap it with this group. So now what happens is if I have those two R groups. For this alkene, let's say I kept these bottom hydrogens, right? So I'm going to put them back. Sorry. And now for the top, well, I already swapped these away, right? This stayed on the other compound, so I just have these hydrogens left to put on. And so I get these two compounds, all right? So you see I swap the ends of the alkenes. So I'll number the carbons of the alkene. So this is carbon 1 right here. This is carbon 2, 3, 4. This is carbon 1. This is going to be, I'm swapping out carbon 2 for carbon 3. So the whole point is I'm chopping the double bond in half. That's how the swap works. This double bond gets chopped in half. This double bond gets chopped in half. So carbon 2 swaps for carbon 3. Now over here, carbon 4 stayed put. And carbon 2, again, swap positions with carbon 3. All right, so that's the overall idea of how the olefin metathesis works. All right, so let's try another example. So this benzene, here's my alkene. We take another alkene. All right, so we use two alkenes in olefin. And I'm just going to write Ru cat. So how do we do this? So what I always do is I always look at the carbons of the double bond. All right. So my trick is I erase the double bond. All right. So I'm going to erase the double bond, but let's make sure that we still know that there's a carbon there, here, and here. And you'll see why I pointed this out. Erase this. I'm going to do it again here. All right. And so here's what I'm going to do. I'm going to show the carbons of part of those double bonds as if they're broken away. There was one carbon of the double bond. There's the other. And so what I'll do is I'll actually draw the originals in case it's not making too much sense. So this is the original compound. What I did is I erased the double bond, but I labeled the end carbons of it, the carbons that participate in the double bond. So that's this carbon and this carbon. All right, so I have that up here. This one you can think of as a free floating carbon. So I'm going to label this, let's say A, B. And let me draw the original reactant here. So we have this. I'm going to again erase this bond and just label the carbons that were part of the double bond. So that's this carbon and another free floating carbon right there. So let's call this C. Let's call this D. All right. So I have these 4 labeled carbons. Now, what you just need to do, if you're ever asked about olefin metathesis, you need to make something new. All right. A used to be connected to B. So what am I going to connect A to now? Well, I can connect it to D, or I can connect it to C. If I connected A to C, I'm just going to be forming a bond like this. Oh. So this was C. And remember, you always need to get a double bond back. Double bond, another carbon. So this was C, this was A. This is exactly what my original reactant looks like if I erase this so you guys can see it. Right? Same exact thing. We just labeled the A and C for our own purposes. That doesn't mean that that carbon is unique. Oh, it's A to C instead of A to B. This is the same exact compound. So I'm not going to connect A to C. I'm going to connect A to D, right? And we're not going to connect it to B, A to B just because that was our original compound. So A and D, if I just connect those 2 carbons, you're going to get this. A, B. So this is just a 2 carbons participating in a double bond. And so we have our hydrogens here, just in case you forget. All right, so that's the product of A and D. So usually what I just like to do is I just like to show a bond connecting them. I'll do it in red. A connects to D, and you always need to get a double bond. So I'm going to draw a double bond with it. So you can see A and D are just 2 carbons participating in a double bond. B and C, connect them, and again with a double bond. Now in terms of the stereochemistry of the double bond, it's the major product is trans, but you get some cis. But the major product is trans. So we know B is going to connect to C, so let's try to draw that. So this is carbon B. Now, B is going to connect to carbon C in the form of a double bond. And we said trans is the major product, so we're going to get this to come down. OCH3, and we get the carbonyl. And if you're a little bit lost in the counting, since I used the letters, let's go 1. Let's label this oxygen as 2. C was connected to 1, and then there's the oxygen as 2. All right, and so you can see that we created this new B and C bond. And you can also kind of see we did lose carbons here. If I count my original compound in just numbers, I have 1, 2. Let's use green actually, so we don't get confused with the purple numbering. 1, 2, 3, 4, 5. So I'm not connecting carbons of the double bonds directly to each other like 2 to 3, right? If we count, that's a total of 5. Whereas here, I'm going to have 1, 2, 3. All right? So you see we've lost some because our other carbons are right here. And in reality, if I actually counter it properly, it's going to be 1 connected to 4 to 5. If I was consistent with my green numbering. All right? And so that's an example of olefin metathesis. Now, one common thing you'll hear is a ring closure metathesis. All right? And so the way it works is we can create these larger than normal rings using this olefin metathesis. But let's start out with a normal sized ring. All right, now let's just again write RU cat. So I put X. X can be anything. I'm not specifying in this case. It's not supposed to mean a halogen or anything, just any atom. First step is always number. 1, 2, 3, 4, 5, 6, 7, 8. Now in terms of the ring closure metathesis, there's kind of two ways of doing it. There's my method that I just showed, and there's another method that's probably easier. The only thing I like to get into the habit of this method because of an example problem I'll introduce later on, where it's just a little bit easier to work through it. So whenever you're doing the ring closure metathesis, the shortcut is to look at the two carbons of the double bond, right? So we have carbons 1 and 2 and 7 and 8, and connect the two closest ones together. That's 7 will connect to 2 to 7, and remember they do form in a double bond. And then we just chop off 1 and 8. So that's going to create this ring. If I numbered again, this would have been 4, 3, 2, 7, 6, 5. See, 2 connects to 7. 1 and 8 were chopped off. 1 and 8, they were chopped off. That their side product. 2 connected to 8 in the form, 2 connected to 7 in the form of a double bond, which is this one right here. All right, so that's a ring closure metathesis, and we can do it with bigger compounds and form rings that are generally unstable. So if I number this, I'd get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just write RU, so we know. Now again, let's just try that method. Connect the two closest carbons. 2 connects to 9, form of a double bond, and we chop off 1 and 10. So here's 1 and 10. Let's just do that first. All right, and now the ring is going to be much bigger. It's going to look a little bit bigger than normal. Right, and if we counted, this is going to be 5. Let's just call this 4, 3, 2, 9, 8, 7, 6. The double bond forms between 2 and 9. Right, and that's your end product. So in this case, we have a ring bigger than 6-membered because in olefin metathesis, we can do it. Right, and you would have gotten the same exact answer if you used this method. So I'm about to show you why I do prefer using this ABCD method. All right, so let's try this problem out. just start over. So we have this compound. All right. And again, argue cat. So what's the product of this olefin metathesis? All right. So in this case, it's a little bit harder. Well, what's my closest carbons, right? So this is why I prefer the ABCD method. Move this downward. So the first step is always to do that ABCD. So let's go A, B, and then let's call this one C, D. Doesn't matter which ones you pick, right? And actually, you know what? Let's even make it easier. So let's go duplicate everything so it'll be nice and laid out. All right. So let's go step 1, A, B, C, D. All right. Now step 2 is we need to break those bonds. All right. Remember, we're erasing the double bonds. So let's try this out. Sorry about that. Now remember, we still have this OR. So carbon B is right there. A is floating around, it's chopped off. This is carbon C. This is carbon D. All right. I always like to put a dot at carbon A just so I know it's still there. All we're doing is erasing those double bonds like this. Right? Just chopping them. Now, step 3. That's where we make our something new. All right? Make your something new. A used to be connected to B. So I got to connect it to something new now. Am I going to connect it to B, or am I going to connect it to C? Sorry, am I going to connect it to D, or am I going to connect it to C? Now, it might be a little bit hard with A, so instead I'm going to look at B first, right? We know it's not going to connect to A again, obviously, it was already there. So D or C, right? Well, if I connect it to C, let's try it. B connects to C, remember double bond. You'd get exactly a 1, 2, 3, 4, 5, 6-membered ring. We did not have that before. We had 5-membered rings. So that is something new. So let's try a 6-membered ring. All right. So 6-membered ring. Now let's number it, or let's figure out where everything is. So let's say I put B as this carbon right there. That means C is this carbon. And that means our new double bond formed right there. All right. That means if B is connected to C, A connects to D. Again, double bond. All right. And also let's number it. You can see that carbon C is going to be 1, 2, 3, 4 away from carbon D, right? And so if we count it again, carbon C is here, 1, 2, and now we have to start making the branching. So we're going to have 3, here's your carbon D, right? I labeled carbon D as also carbon 4. Let's put the 4. That means carbon D is going to be bound to carbon A. Again, double bond. Now, why did I nose branching, right? Carbon D instead of just continuing along this, the ring when I was counting? If you look, if I just erase this bond here, this is our ring right here. coming all the way around here. 6-member ring, that's 1 bond. 2, 3, 4, 5, 6. This is our ring. All that shaded in. And you can see that carbon D is connected to this chain, which is outside of our ring. That's how I knew. All right, if it wasn't obvious. Okay. And so the only thing we're missing is our OR group, and that's on carbon 2. And so let's just put that here, OR. All right. So you can see how it's step by step. First thing is label A, B, C, D. Next, erase your double bond, and I like to put these little circles so I know where all those carbons are. And then just got to make something new. You're not going to reconnect it back to the original carbons, so just connect it to something different. And it could be a trial and error thing. You can connect A to C and realize, oh, that's not going to give me anything. So, and that means B and D can't give me anything. So try B and C. You'll see, oh, I got something. Then it's something new. And so then A connects to D. And just please, guys, this is the best piece of advice you'll get. Number your carbons. This, when you're doing olefin metathesis, it is extremely easy to lose track of your carbons. Very, very easy. All right, so I urge you to get into the habit of numbering your carbons. All right, I hope this video helped you guys, and so I will see you in the next one.